Good evening, everyone. Good evening, Mr. Henrik. Is my voice clear?
Yes, I can hear you.
Thank you. Thank you to each and every one of you, actually, for being here with us today. Very pleased to be able to welcome those who have been with us for a long time and those who are new to our SB student chapter. Also, we'd like to draw your attention for an upcoming, very full of knowledge 2 hours session. Um, Today's lecturer is a man of a large and big and honorable service and experience in the oil and gas world, Mr. Henrik Suryadi. I'd like you to welcome the man, everyone. Uh, Before I start with the biography, um, Mr. Henrik is a principal drilling engineer and digital product champion with a demonstrated history of working the oil and gas industry for 21 years, skilled in drilling and well engineering, logging, directional drilling, and well engineering. Uh, Directional drilling and digital product development. Uh, Mr. Henrik has 6 patents and published 18 SPE technical papers, bachelor's degree in mechanical engineering from Institute of Technology, Bandung, ITB, Indonesia. Mr. Henrik, very glad to have you here with us today, and the microphone is yours.
All right, so thank you so much, Yusuf. Thank you for the invitation, and to you all. So good evening. So thank you for taking interest on this presentation and making yourself available in this evening. Is an honor for me as well be able to talk to you all as the students, especially in this topic, because this is something that industry trying to work on and trying to catch up with compared to the other industry, and how to use digital technology on to changing the way of working in oil and gas, and then improve the efficiency and bring the step forward improvement that we can do in this industry. And the good, I mean, the critical things is, as I say, this is still a journey, and then people who will become a key player is most of you who currently is student, but soon you will be joining the industry, and we we expect you will be involved more on those in this transformation journey. So let me share my screen. All right. Just give me a feedback if you can see my screen clearly.
Loud and clear, Mr. Henrik.
All right. All right. So the topic of my talk today is digital transformation, especially in the well construction, because my background is in drilling, and and hold on, let me set it up. All right. So my background is in drilling, so that's why I'm involved mainly in how is constructing the well. And at the end, I put a little bit. No, this are you ready? The key thing is about, yes, we want to do digital transformation, but is industry ready? And also, if the next generation is ready, understand what is this digital transformation and what things you can prepare even from now, while you are still as a student, by taking benefit things that you can learn now, so you will be ready when something is changed in the oil industry, especially related with this digital technology use. So so people are talking about this digital digital transformation. And then when people talking about digital transformation, people start talking about the future. How is the future oil and gas when we start using digital technology? People talking in, especially for example in this one is World Economic Forum. How is the landscape of the job is changing with the digitals? There is a growing demand of job, mainly related on people who have a capability to be involved in digital related technology, and some digital also replacing some of the role through automation, right? And the same thing happened also with people in oil and gas. Is that curious? How is for example my generation right now who been many years working in oil industry. I used to get a question, right? How is the future of my job? My job is going to be replaced. I think the same thing with you all who currently study, especially study in petroleum or study in engineering. Some of you probably wondering, do I still have a job, or what would my job look like in the futures, right? Some people is go extreme and say, is everything going to be replaced by a robot? So what I'm gonna show you today, I hope it's not. I don't need to take this long 2 hours. I will be more than happy to have discussion with you at the end. Or if you have any question, just feel free to jump in and ask me a question, right? At a particular slide or particular point that I'm going to talk about, feel free to stop me. Or if you can willing to you want to put it in the chat, you just type in your question in the chat. I hope the moderator can help me raise any question uh, on the chat, since I'm not able to monitor what happened in the chat. So I'm just gonna go through what is coming. So to give you an idea, how is the future on an oil and gas industry, especially in oil construction. And at the end, I'll talk a little bit about how to make you yourself ready, right? I think it's more relevant for you after you know what is going to come in the futures and how you can, starting from now, to preparing yourself, right? So if you're talking about digital transformation, people have been talking about less we do digital transformation. It's not about just technology. Yes, there is a digital technology, cloud, machine learning, automation, and all those things. Yes, we're developing technology. But when we're talking about digital transformation, it's not just I have the technology and then use it. It's actually about how you changing the culture on how you work, how you operate, how you interact, how you collaborate by taking the benefit of digital technology. But you have the willingness as well to change the way you're working, right? So not just getting a computer, getting a new software and everything, but also using all those technology. I'm changing the way I'm working, right? And changing the culture is this is the main challenge of the successful digital transformation. So openness, people willing to, okay, there's new technologies coming, right? Some people need to learn how to read, but also some people willing to change the way of working. So what is the motivation? Why people in oil gas industry talking about the digital transformation? Because there is a promise by using a digital technology, right? This is some estimate being studied by some consultancy company. How much is the impact on the cost or global expenditure in E&P industry or oil and gas industry on this various different aspects. There is improvement 7 to 30% on the success of exploration well. There is improvement 9 to 37% on how we improve the efficiency of well construction, how we efficiency in development and planning, and what important is how we can improve in production. So this is the amount of saving based on the study being made by some consultancy company. In terms of number, if you're talking about just a number, where is this 60 billion to 290 billion is coming? Is just that if we drill 20 exploration wells, at least you save 3 of them. You avoid to having a dry holes, right? So 3 over 20 wells, that's just quite improvement. the time that we spend for processing a seismic, it will be significantly safe, right? You allow us to, because we can interpret the data better with digital, making decision better. You can expect it to discover more oil and gas field, and also some operational safe in terms of capex, operation expenditures, and the amount of production, right? But if you look at ourselves, so seems digital technology is promising, but if you look at other industry, oil and gas is quite way behind in start implementing this digital transformation. We just a little bit ahead of public sector, right? Tourism, people already start buying everything online, and some good recommendation when you're trying to buy a ticket. It's that recommendation because start learning, reading from your data or learning from the data or your behavior is start proposing that. The media, you familiar with what is all the advertisement proposed by social media, telecommunication, retail banking, you name it. We just bit behind of the health, and we just ahead of public sector. So we are need to chase, and we can learn from other industry on how utilizing digital technology to help us improve, right? So, but having said that, right, even like overall oil and gas industry is like we are behind, but it's actually the journey of the dream of automating things is already starting long way ago. Well, I mean, long time ago, right? Since 1970. This is something that we developed, especially for example, drilling tool. We start developing the first electric drive power swivel in 1970. That's the building block to start automating the machinery that we use for drilling. The Setco drill ship is start developing an pipe racking system, how to grab the pipe and making up the pipe. And then go up to 1985, after all this pipe handling in the rig, and we start developing some rotary steerable in 1996. And then because we have rotary steerable, we can embedded some automatic steering. So for example, what is automatic steering? For example, like you driving a car right now, you have a cruise control, right? My old car has been in 10 years. You can, let's say that I want to keep the speed at certain number, let's say 100 kilometers per hour. You're saying that the cruise control, you don't even press the gas or everything, it will try to, because it's reading the speed, it will try to adjust the gas automatically, right? The next cruise control is how it can, if you say I want to go straight, if the wheel start drifting to the left, it start correcting it again. So rotary steerable have those capability, and even the full advancement rotary steerable is already happening now. In 2004, we start even sending data from the rig to town, and then we can start controlling some of the equipment from town, right? Which is, this is what's happening in 2004. Schlumberger have the rig in Cameron, Texas, in the United States. This is the rig. We install 2 computers to reading the some data from the rig, but also this computer attached to how we can control the pump, how we control the top drive, and how we can control the drawhook for applying weight on bit. And we have our engineering center in Cambridge in the UK is start monitoring the data in this facility, and then we start sending comment like say, okay, I want to push more weight on bit, and it's sending the data through satellite, and then it's reading by this machine, and this machine is controlling the machinery. So the remote operation, we call it remote operation, how we can trying to remote control rig equipment is already started since 2004. Of course, this is the early journey of that, right? Right now, when 2020, when we have COVID happening, suddenly everybody have to work from home. We already have this building block monitoring the rig from town, right? We're sending the data through internet, and that's applied in 80 countries where Schlumberger operate. And we apply this, what we call it, remote operation in 60% of Schlumberger job worldwide. To do a directional drilling is basically we controlling our steering tool, rotary steerable especially, we taking survey and logging from our MWD, LWD automatically in town. So on the rig, people make it up the BHA and then the BHA running in the hole to drill well and then sending the data to surface, and then from surface sending through satellite to town. People in the town can see the log and monitor all this well, accepting survey, and even doing some testing and intervention. So by be able to do this, we minimize number of people that have to go to the website, to the well site, right? So more than almost 7,000 people personal trips through this 84 country operation is being avoided because of that COVID. People start getting restricted, and we drilling 6,500 section, number of section that we have to drill through this setup. So if you see that one guy looking at the so many computer, this is each of these 4 computer is one well. So it's basically this one person monitoring 5 wells and taking action for 5 wells. For sure, it cannot be done if we have to look at one by one. So we taking the benefit of digital system that can do a smart monitoring. You set up the the condition when something happening, and then just pick up the alarm, and then this expert just need to look at when the alarm calling him. Otherwise, if everything running as a normal, he doesn't need to look at the screen. So we embedded a smart monitoring. How we be able and doing a smart monitoring, we need to predict it, right? If something happened and then stuck, it's too late. We need to be able to detect something happen before it's actually happened. So that's what we being done by predictive analytics through machine learning, and we following up how is the trends and event, and through this the data that it should give us also insight how is our performance, right? How much time we spend for each different activity, either making a connection, drilling on bottom, cleaning the hole, etc. Because then based on this we can improve the next well performance, right? So this, because the capability of transmitting the data, monitoring it, and having all the smart capability, this what would help us during the COVID. So so we look at when we start the industry start digital transformation journey, we look at what is the available digital transformation technology that we can use. So I'm gonna talk to you some of this example. For example, how we use cloud computing, how we use machine learning, how we use a smart sensor and everything, right? So let's have a look some of the example of the application of this digital technology. First is a cloud computing, right? It's basically your laptop or your computer. This is the computing power that you can get. If you yesterday I went with my children who currently still 11 years old, but he already start talking that I want my gaming computer with this processor, with this RAM, with this GPU, blah 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 blah. I was thinking, wow, all this computing power, because yes, I need those computing power, be able to play my game smoothly. But that is the traditional computing power, which is whatever being installed in the hardware. Then imagine you can access this computing power, which is scalable. When I say scalable, it's depending what you need. If you need to do a simple calculation, you take just a small part of this data center, right? You just use probably one node of this server. But you say that you start doing modeling, rendering some complex mechanical earth model, then you can expand to use more computer. That is the difference between cloud computing and the traditional computing. Is the amount of computing power that you can use is scalable depending what is the need, and you just need to pay as the power that you use. So if you only use it for a simple calculation, then you pay a small amount or probably nothing. And then if you need, by the time you need something, then you start paying more, right? But this will be cheap rather than you keep expanding the capability of this laptop. So we start implementing this cloud-based platform in our environment called Delphi. Delphi is like, if you consider like Apple product, you have iOS, or other thing that you have Android, it's like a platform. On top of it, on top of iOS and platform, you can build different application, right? So Delphi is, you can just look at similar like that. Is the environment, is the operating system on the platform, and it come the way on the standard ways how you store the data, how the security control and etc. On top of it, we building different application that being used starting from exploration, field development, how you doing your planning, drilling planning, drilling execution, and also production, right? So I will focus, because it's well construction, I'll focus on two items that being used for well construction, which is drill plan, which is the cloud-based planning solution on how you be planning the well in this cloud-based system, right? And also then drill ops, how you start executing your drilling program and taking the benefit of some automation and smart interpretation, right? So let's look at drill plan. Again, drill plan is a cloud-based system. We're taking with the benefit, putting it in the cloud, instead of like, I don't know, what is the traditional software that you heard before during your study? Probably you heard Drilling Office from Schlumberger. Someone, Joseph was asking me if I using drill bands. Probably you heard some landmark software called WellPlan. So that is the traditional drilling engineering software. Is you install it in your machine and you use it for doing your planning, trajectory planning, casing design, and you calculate torque and drag and hydraulic, etc. Right? So now we look at drill plan. What is the different drill plan compared to those traditional drilling engineering application? Right? First thing, we build drill plan as a collaborative space. We want, instead of people, each individual person working in their laptop and looking at their machine, and then they spend most of time in the meeting talking about it on email. Why don't we just bring everybody? Let's say this is a project or a well that they need to plan. Why don't just give them access to all the team members? So you see, the first thing is, because it's a cloud-based, I don't know, probably you're familiar with Office 365. Well, you can share document and many people can edit those documents live, right? So pretty much the same concept. But now what we need to build is a drilling program, not just document, but every single aspect design of drilling program. There is someone designing trajectory, designing wellbore geometry, casing design, BHA, operation parameters, drilling fluid, etc., etc. So you in well construction team, you can pull different people to taking care of different aspects of drilling program. So that's the first step. Instead of working individually in their own laptop and start sharing the data through email or through USB stick already, now we're just pulling everybody to the cloud. So people can work from anywhere at any time, right? So that is the first step. The second step we want to change by drill plan is how we're taking the benefit of different engineering calculation. When you're doing design trajectory, you design casing design. There is always some engineering analysis to be run, and then you will check if the expected load is gonna make something break, right? For example, the torque and drag. If I calculate my hook load, is my rig can capable to pull the weight of my string or my casing? If during drilling, if my drop drive can handle the torque. While drilling, if I'm pumping through my hydraulic calculation, can the pump handle the pressure or something? I cannot continue drilling because the pump cannot deliver the flow rate that I'm expected, so I cannot clean the hole. Through the cloud computing, because we have pretty much unlimited computing power, we want a quick feedback. Whenever you're doing design, you change something, it at the background, it automatically doing some torque and drag calculation, hydraulic calculation, and various different, if you see here, maximum overpull, BHA tripping speed, everything, and then calculate the result and then compare it with some standard, right? Buckling, you have a buckling limit. Hook load, you have the rig hoist limit. The total torque, you have a top drive, the torque limit, how much the top drive can deliver, and also how much each joint can handle the torque. The stress, how much is the pipe grade, right? The pipe tensile strength or yield strength, right? You compare with expected load with that, and then you can, what you see here is like a traffic light. So while you're doing design, if you submit the new design, it will automatically calculate all those different calculations. It will compare to the limit, to the standard, and it will just the rule, right? If you exceed the limit, the rig, the equipment, or rule of thumb, then if you exceed, you just fail. If you close to the limit, is a warning, it's showing as yellow like this, or if below the limit or within the tolerance, this is green. So it means everything is okay. Your rig, your equipment, it can handle the load. Then people can just focus on, okay, now I have issue with my hole cleaning is red. Then I need to see what thing I need to change. Is my mud? Is it my flow rate I need to increase, or I need to rotate the string faster so it can stir up the cuttings up, and many things that in the future even the system should capable giving you the list of mitigation. If my hole cleaning is bad, it giving you a recommendation, please increase your flow rate. And then you as an engineer says, yes, I agree, or no, I not agree. And we want even the software, as the software keep asking you this, it record also the behavior, right? What is the preferred way to solve the issue? And next time when giving you recommendation, it understand you better, that every time you have hole cleaning issue, you prefer, and in this kind of case, you prefer to increase the flow rate rather than changing the fluid, for example, right? The other thing is, we want to automate some of the way we're doing design. For example, I don't know, some of you probably already learned how to design trajectory. Basically, if you have surface location and you have a target, right? The geologist or the GNG giving that this is the target of reservoir I want to hit. Excuse me. Right. So not right now, people designing trajectory is just start drawing a line, right? From surface, I'm gonna drill a vertical from surface to this kickoff point, and then I build, and then you basically connecting the line until you hit the trajectory. And normally, even we have some job called well planner. Their job is just designing this trajectory. They are so good because they're making trajectory every day, and they become expert how to come up with the best trajectory. But in other industry, for example, like, I don't know what is mapping application you use there in Iraq. For example, I don't know if you use Google Map or any other map application like Waze or anything. It's basically you just tell where are you now, where do you want to start, where is your destination, and when you click search or you run, it's basically proposing you the best route, right? It's better go to this route, it's much faster and everything. So we are wondering why we cannot do that in trajectory design. If you know the surface location, I give you the target, can you tell me all the possible path of this trajectory? And this is what we come up with, this drill plan automated trajectory design. You give this starting point and the end point. You can give a constraint, how much dog leg, how you want to approach the target, etc. When you apply a constraint, it calculates all the possible path. So in this case, I don't know if you can see the number. It said the solution found is 426 trajectory. So instead of you doing it one by one and you keep modifying, you don't know it's improve the efficiency or not. It's straight away telling you there is 420 possible solution. Now, how you choose one out of this 400 is depending what is important for you. Is it the length? I want the shortest length of the well. Then you can changing this filter, or you want to limit the number of dog leg, or you want what depth you can kick off. So based on this, we call it key performance indicator. Which one is more important for you? It will pull the solution out of this 400 and propose it to you. Then now at this point, instead of you design it manually, you just need to select that what you believe as the best trajectory. The computer is already calculating all the possible option for you. Not only that, if you're familiar with anti-collision, it's basically how we need to avoid that we hitting another well. In the background, every time we propose the trajectory, it automatically calculate those engineering analysis to tell you you have a collision risk or not, right? So the other thing that we can do that changing the way we working in well planning in this traditional application. I don't know if you're running an application to calculate torque and drag, or probably some of you are still learning how to calculate it even manually or using Excel. It's basically you provide input. This is VHA, this is trajectory, this is the whole the well bore, everything. This is fluid properties, and then you click run. It calculate through hydraulic engine, computation engine, or torque and drag computation engine, which is finite element modeling, and then they give you a result. After you giving result, you see the result, and then you say, oh, okay, sorry, my pressure is exceeding the pump pressure limit. I need to change something. You modify the input again, and then you click run again. They say, oh, still limit again. Then you keep doing that. You keep doing that iteration. With the cloud computing, as I said, that cloud computing is scalable. I can use the amount of computing power as needed. Why don't just I submit all the possible scenario, right? So in this case, what we call it is sensitivity analysis. I can calculate. I want to calculate from the top section, the intermediate, until the reservoir section like this one, 7 runs. Go through this interval. I want to calculate all the hydraulics on torque and drag. And then I want to calculate every 100 feet. And I want to calculate for 4 different weight on beat, 4 different RPM, 4 different flow rate, 4 different flow density. And at the end, it's basically you submit thousands of scenario being calculated by the engine in the cloud, and then give back. So that's why this chart showing so many lines. In this is what you're looking at. Probably some of them is behind this line is 625 scenarios. And then, so instead of you looking at one by one, now you have everything. Then you can clearly see which one is crossing the limit, right? You can play around with this filter. Then you clearly see that in order to not avoiding to crossing the limit, I know what configuration of these parameters that can achieve that, right? So instead of trial and error one by one, it run the calculation, thousand of calculation, and give it back, and then you using this dashboard to analyze the data, right? So that is how we taking the benefit of cloud as a collaboration space. People can access anytime, anywhere, and also the computing power that we cannot get it before in this traditional, for example, just limited by your CPU or by a laptop. Okay, so any questions so far? I've been talking, continuously talking, and then okay, someone already answered what's kickoff line. Any comment, any question? I just want to check if everybody is still clearly following me. Everything still good?
Mr. Can you hear me well?
Yes, I can hear you.
Let me check if there's any questions. Okay, here's a question. What is a KOP?
It's a kickoff point. I think someone already answered that. Yeah, it's the kickoff point is in which point you are starting deviating from vertical, right? If you're doing directional well, that is you normally dealing vertical first until a certain point you start building up. That's a kickoff point. How are you kicking off to out of vertical? Yeah.
Right, Mr. Henrik. No more further questions. You can,
okay.
You can
all right.
Go on.
I'll continue. So that is how we using a cloud computing to change the way we doing it in real plan. The next thing is I'm talking about the data. Oil and gas industry has been using data. We always collecting data, reservoir data. We're doing a lot of loggings, when we're doing seismic, we're taking a lot of data. Same thing with the drilling. We put sensor everywhere. There is a weight sensor, torque sensor, pressure sensor everywhere, right? The latest development rig, we want to digitalize everything. It hundreds of sensors being put anywhere. But now the issue with the data is we like to collect things, right? We like to collect the data, but not necessarily we can use it. Sometimes, you know, I don't know, 80%, 90% is just goes waste, right? Because we have limited capability on how we can evaluate the data and use the data. And the issue is sometimes the data between one provider, one company is not a standard. So if you're already starting with something not standard, you already spend time on formatting the data, converting the data, then you don't have a time even to do analysis or even making decision. So industry realized that that's something. Come on, everybody, we need to sit down together so we can make a standard data on how being stored. So then various company can do innovation on building application, but everything is already standard from the data level. So that's where this the consortium or the agreement or committee between various operators, oil company, and now I think it's more than 175. I think it's 209 or 210. It consists of oil company, service company like Schlumberger, Halliburton, Baker, and digital technology company like IBM, Microsoft, even some university, sitting together on try defining what is the standard way of storing oil and gas data, right? And the idea is if everything is standard, then people like you guys, right, or startup, I want to create an application to process, for example, this data or to do machine learning this data. Everything is already standard, and then you can sell it to everybody. It's not like, oh, I'm making application that can only work for a company that using this type of data. The other one, because different data I cannot use it. No, now is open up the opportunity for many company, many people, many smart people, startup, that everything we make it standard. This is through the spirit of OSDU. So now, if we already standardize the data, this is what we're talking about, the big data, right? We've been collecting amount of data. Of course, when we say talking about big data, is the volume of data. The volume of data even is huge. It's not as big as what being collected by the social media, for example, right? They are hundreds of times can be bigger, right? Because it's been happening daily and then involving millions of people, right, across the globe. While we are focused on what is being collected in the well, right? But the spirit is still we treat it kind of as big data, and of course to populate this big data, especially on some old well, we need to digitalize our reporting, right? The data that coming from rig cannot be written in the big book manually, otherwise then the computer cannot read it. But there is a way to how digitalize some of those report. There is natural language processing, can scan whatever, let's say their hard copy printout, and then become digitalized and store it as a digital data. Or people start reporting in the digital drilling report itself using apps, using a device that people can type it in, and then we start trying to fill up this automatic drilling report automatically through what we're reading from the sensor, right? And then so using this data, again, the standardized by OSDU, and on top of this, then we can start enable some automated machine learning, right? Using Google Cloud, Dataiku, Microsoft, or different company can provide tools to do this machine learning. And then the result of machine learning, we need some like a business, like a Power BI or TIBCO, is a to dashboard to view the result, right? And then after that, then you can use it in many other application. So the key on this big data, populating this data, is we need to digitalize the report. We can help with the natural language processing to read some of all data and make it digitized. we need to ingest it from various different format that currently we have. We need to transfer it to make sure become a standardized format now. And we keep adding more sensors on the rig to reading, various different data, right? The gas sensor, your tank level, your flow rate, and everything, right? So this will populate your big data. And if those big data available, then that's it. You can develop machine learning. And I can talk a lot about this, but you can find it now in many SP conference. There is always presentation about the use of machine learning, artificial intelligence, taking the benefit of the data. So this is some of the paper you can in the SPE, right? How to use machine learning based on the offset experience to predict what is the rate penetration of the next well, right? How I can optimize my drilling parameters. What is the best drilling parameters combination that I can use for the next well? My prediction on safe operating mud with window. How I can classify the stack pipe and then trigger a predictive analysis and trigger the alarm before it's actually stuck. Right? Again, formation tops and everything. Many things, many area is taking the benefit of those big data and then use a machine learning technique. Right. The other thing is what we call it hybrid modeling. Many of current engineering analysis, like a torque and drag, hydraulic, casing design, BHA tendency, is based on mathematical modeling, right? We understand the physics, we understand the chemistry, the fluid dynamic. Someone come up with a mathematical model. That's what we call it a physics model or a mathematical model. The challenge with those physics model is there is always things that you cannot capture in the modeling, right? Especially while you're drilling. There is many uncertainty because you're drilling with the earth. There's also something that's not part of the model, and it required some expertise on this, experience on this, to be able to interpret the result. Sometimes when you run it and then get the result, you're wondering why the result like that. It requires some experience, right, to be able to understand the result and then thinking what actually happening downhole. Why the modeling? Because sometimes it's confusing. Is it the modeling is wrong, or is it actually happening like that? And you cannot visualize it, right? And it can be time consuming to run it. Another thing is now we start introducing what we call it machine learning model on how, based on the data, how the relationship of the data, right? You can also using it to predict a similar well or similar condition in the next well, and then what is the expected result, right? But the challenge with this is you need a lot of good data, not just a data, but the data have to be in good condition so it can be used to learn and to model, right? To do a modeling. Sometimes it can conflict with the physical modeling. Said it how the machine learning said it. If this condition happen, it is what happened, but this cannot be simulated in the mathematical modeling, and it can be difficult to interpret because it's just trying to find to analyze the relationship between different parameters and then the result, right? So, but we want to taking the benefit of the two words. One is the mathematical modeling or the physics modeling. One is the machine learning model, learning from the data, and that's what we call hybrid modeling. So we can start with physical modeling, but to filling up the gap for those things that not being covered in the modeling, then we start using it what the data see. And the taking the benefit of these two words, it help us to model more accurately. So our planning even more accurate, right? And it's easier to analyze, interpret. So it can be used even for by junior people, and it helps us to run this modeling faster. So some of the use of this is what industry called digital twin. What is digital twin? Is instead of I have the physical measurement in my rig, my drilling system. Sometimes you cannot put sensor in some place, right? But you really want to know. For example, I want to know the pressure here, right? I want to know the pressure there. We cannot just easily put pressure anywhere. But if you can model this, the entire system, let's say in this case is you model the hydraulic, and you can get an accurate modeling of this entire system, then we pretty much can check what is the result of the pressure here, pressure there, pressure there. That is what means digital twin. I can get a pressure information on any point based on my modeling, right? So the same thing that many being used, for example, like in the turbine in the plane, they want to know how is each individual blade or everything operating, but they cannot put sensor there. But give me a minute. Can you hold on? Sorry for that. My daughter is calling. Yeah. So you cannot put all the sensor in this jet engine, and the way to do it is to have a digital twin, and then connect it with all this information, the finite element modeling, CAD modeling, operational data, maintenance history, to check the condition and to predict when is the best time to do maintenance to this engine. Then the same thing also apply in the rig. so that is the use of machine learning to fill up the gap on physical modeling. As you imagine, now we're dealing with the big data, right? A lot of data to interpret. You doing modeling also generate more result. We need a way to visualize it. It can be overwhelmed. So as simple like in the well engineering, we use a lot like a scatter plot, right? X and Y. Now because the amount of data and then displaying multi-dimension, we call it multi-dimension. You now not only just a simple, I have two parameters X and Y, and then the result is Z. Now probably you can have 6 parameters and it's affecting one result, right? In order to do that, you cannot just use this X, Y, Z chart, right? Or bar chart or whatever it is. You need different way, the new visualization chart. And there is many development on even this visualization. There's a dedicated domain or expertise on this subject, and they can create something like this. Is what we call parallel line chart. This four point is the input. This 3 point is the result. How is the relationship between 4 input to 3 result? And each of this is scenario. This is what we call it counter plot, right? And many of this non-traditional chart. So this is area to expand. The idea there is we want to have in the system, when we have this big data, how when engineer look at it, they can easily getting summary or getting conclusion or getting insight, so they can make a quick decision. And that's what we need during well construction. If it take time, to people to understand everything, then it's not improving the efficiency, working efficiency. So people developing the new way of visualizing it, and in the end is helping user to get the information, to get the insight and making a decision, right? So that is what pretty much changing on the way we planning the well. Now let's moving how we want to execute, how we want to drill a well, how we want to do well construction, right? There is something, remember I said that the journey to trying to automate things is been starting long time ago by start building, start making the mechanical system on the rig and everything. And now the journey is no longer just to do automation. Now we want to change from automation to what we call it autonomy. What is automation? Automation is the process to perform something without human assistance. So it's being run. You set up the program is well-defined set of parameters, but it very restricted on what things to do. For example, automating the way you handling the pipe. It's just, we know you tell the machine, you go forward, you grab the pipe, you pick it up, you come back, you put together, you make it talk. So that is very well-defined set of parameters for the machine to do. Like I talking about this cruise control. It knows when I press the number that I want to keep, you monitor the speedometers. If it's below, increase the gas. If it's is faster, press the brake and everything, but doing it. So this is very restrictive task, and you can program it. In autonomy is when the machine doing those automation, but also start be able to be aware. If I'm in normal condition, I will just follow whatever predefined task. And but if something happen suddenly, for example, like a cruise control car, right? If in the cruise control said just go straight, you go straight, the car is go straight, and suddenly there's something pass by. That's what we call it uncertainty. How the machine understand that need to do to avoid hitting those things in front of you. The same thing as well while you're drilling. Drilling after suddenly there's a kick. How the machine understand there's a kick and then do the mitigation action rather than expecting human to taking control, right? Because at the end of the day, human have limitation in terms of the speed, how fast, and also depending on the experience and the expertise of the person. So that is autonomy. How it can run automation but fully aware of the condition and even learning from the past experience, right? Taking the benefit of the machine learning and everything. So we're starting from everything is human operated, and then the human start assisting the machine, automated. You press a button and doing the action, but until fully autonomy, when the human tell that this is the drilling program to the rig, to the machinery and rig. You program it, the rig said this is the drilling program, please drill well from this, and then hit all this formation, blah blah blah, and you just relax, standby, right? That is still the dream, and we believe one day we can achieve that, right? Some of this autonomy is already embedded when we sending a rover to the Mars, right? We only control from the Earth, but some of the we don't even know what is the rover in the Mars will face, right? So what is it capable doing in now in terms of this autonomy? First is what we call it auto ROP. How the machine can decide what is the best parameters, weight on bit, RPM, and flow rate to use to achieve the highest aero ROP for a particular formation, and it learned by itself, right? So those capabilities is already available through auto ROP. It always reading the data. I'm in this formation. How is the vibration level and everything, and then it keep pushing the parameters to achieve the highest ROP. Drill a stand from the way the machine pick up the pipe, and then how is lowering the pipe, tagging the bottom, start rotating, start circulating. Now the driller can just press a button and everything being run automatically by the by the rig machinery. The driller just need to watch, right? So that's called drill stand. The good thing, if machine doing it, is more consistent. That's why it's saving the amount of time to do it much faster than just human start handling it manually. Downlink, sending a command to the downhole tool to changing the way we steer or changing the way we record things. Now the way we do it is either we pumping a sequence of pressure, or we changing the sequence of the RPM. But now instead of human doing it manually, changing those flow rate, it just press a button and then the machine send the pulse, the pressure pulse automatically, then make it to send command faster. The same thing. This is, for example, if you're drilling and suddenly there is a vibration, how the machinery know there is a vibration? I need to change something to avoid those vibration. Then that's a dysfunction motivation. So even now with rotary cerebral system, you can program the tool. Let's say I want to drill vertical, I want to build, I want to drill tangent automatically. So the job of directional drillers become more easier because now you just tell that this is the plan that I'm going to use. Then let rotary cerebral auto steer by itself to go through this different section of the well. So this is what we call automated directional drilling, right? So that's how what happened, how we move from automation to autonomy in execution. What else? Well, there's many more. We're talking about virtual reality, augmented reality. First is virtual reality. We use it, many of these, instead of sending people to the rig, we're just sending people to the room. They are using this VR, and suddenly they feel they are in the middle of the rig. And when we train people, right, it's like they are on the rig doing these different tasks. The other thing is when people dealing with the well control. I don't know if some of you watching this the whatever the Deepwater Horizon rig, the movie, the key on blowout situation is how fast you can making decision. And sometimes people have to making decision in this environment. So if we train a pilot, when we train the pilot in various conditions, suddenly there's a thunder, what they need to do, suddenly something is failed, what need to do. We can also train our driller the same way, right, through the simulators, and including make them the feel that they need to do something. Let's say there is a fire, there is an explosion or something, they need to know what to do when the actual happen like that happening, right? But they need to be trained in the situation. Augmented reality is like a glasses, Google glasses. When you looking at equipment, like operator looking at equipment, they can take a picture of the equipment and then they know what is that equipment. They, you can tell that Google Glass, give me the operating manual or maintenance manual of this equipment. It lists you some of the action. So that's helping people seeing some data while they can walk around, doesn't have to be monitoring in front of the screen all the time, right? The same thing also when they look at, like the movie and Avengers, when Tony Stark building thing. So that right now is not as good as that, but through the glasses they can see those different component inside and everything. Some modern manufacturing, like a 3D printing, right? The problem with the challenge with the current bit design is limited by the way we manufacturing the bit, right? So that's why the shape is depending what is the capability to create the shape. But if we can 3D print the bit, then we can experiment with various kind of the shape to make the bit to be more effective on cutting the well, or make it cheaper. Instead of making everything from the strongest material on earth, I know that the only thing that I need to make it strong is this part. Then I can 3D print it, this one, and then attach it to the body that doesn't have to be as strong as this. That's making it cost effective, but still improving the performance of it. Or it could be this can be replaceable. So there's this 3D printing technology open up the way we can develop the bit. And you don't be surprised if in the near future the bit that you will see come up in the market is no longer not have completely different shape than what the bit available right now. Machine vision through the CCTV, like a simple like CCTV like this, it monitor, doesn't have to be someone, HSC officer walking around. Now it's just the camera, and it already being programmed. If someone crossing a certain area, it trigger the alarm, right? It warning people you are in danger zone, or even sending notification to the supervisor, right? It can monitor also the flare, right? The flare, if the flare in this color means something is not optimum, something need to be changed. So something like that is capable through what the machine can take a look and then read and compare it with the database, which one and when have to trigger alarm, when to trigger a notification or reminding people to make the area become a saver, right? So that's just pretty much a quick overview. How I hope you get an idea how we start utilizing various different digital technology on try to changing the way we planning the well, we execute the well, right? And the way we operate while doing, especially during the well construction. So now I want to touch on your thinking. Oh, okay, everything is about digital. Do I taking the wrong wrong major, right? Should I just move it to computer science or anything? Should I need to become a data scientist, right? The the issue is if you are a person which is an expert in the oil and gas domain knowledge, either you are very good on reservoir engineering or you're very good on drilling or in completion, you know expertise in a specific oil and gas domain. You're also good in math and statistics, but also in the same time you know how to program. Then you are really a unicorn. When I say unicorn, is very rare. People have all this capability in this area, right? But what you can prepare from now is no. I mean, an industry will not achieve by developing a person or recruiting people who can major on those this area, right? The industry, what the key is a collaboration. There is someone who the job is data scientist, is being educated in how processing the data and have experience on that, knows how to process the data, what the technique of machine learning need to be done, etc., etc. But there's always domain expert, like myself. If you think that I've been talking digital and you think that I know how to code, no, right? I'm a domain expert. My background is mechanical engineering, and then when I joined Schlumberger, I've been working is mainly is in drilling. So I'm I'm developing my expertise in drilling, right? From a junior until now, I'm a principal drilling engineer, right? So I'm a domain expert because I'm being educated in domain, experience in domain. I know how to use some engineering tools to design the wells. I know what data being collected when we're drilling wells. I can tell that, let's say if you're looking at the reading, for example, the pressure, I say suddenly, oh, the pressure is this value. I can tell. Suddenly the pressure is different. I can tell. Oh, that is bad data. That's impossible. I can get that pressure, right? So you have a sense of because of the experience and knowledge. I know check they tell this is bad data, this is good data, right? And so if there's no collaboration, if everybody is data scientist, it's pretty much like this famous story of 7 blind men and an elephant. Data scientists, when look at the big data, they can see this part of the data, the other people can see that part of data, and then each of these data scientists can come up with different conclusion, right? So in order to avoid this, in the collaboration, in any use of digital technology or like application of machine learning, everything, there should be collaboration between data scientists and domain expert to guide this, to avoid this blind man looking at some part of the data based on their limited knowledge. So what we need is collaboration between data scientists and domain knowledge. What I want to achieve is this capability. So this is how advancement in the data science, this is advancement domain knowledge, right? And when two sides having the top of those knowledge or capability, then we can achieve this, right? How we can use the digital or the data analysis to do a predictive and diagnostic analysis and optimization, right? So This is what look like if a domain expert like me, I'm domain expert in drilling, or you probably domain expert in reservoir, domain expert in completion, everything. This is the task normally what we're doing in our job, right? We spend some part of the time to find the data. We always, telling the data is difficult. We're doing some tasks, repetitive tasks. I need to design the trajectory manually and then keep trial and error. Some big part I use it to coordinate, calling that I'm sending this to this, I make sure everybody using the same data and everything. And then only small part, then I use it to do innovation, to do analysis and making decision. What we want to achieve in the futures through the help of digital technology is some of these tasks is being done by the machine, through machine learning, through automation of digital technology. And then this is what we expect. We have less time to find the data. If everything is standard, that's our spirit of OSDU. Repetitive tasks, if it can be automated, this will be great. Then I don't need to do those repetitive tasks. I still have to coordinate logistic and everything. Probably I still communicate to the people, but this is what being expected as an engineer is to spend more time on doing innovation, getting an idea, to analyze and making the decision, right? So we want to change from this kind of time distribution to this one with the help of digital, right? Artificial intelligence and machine learning. So how you do it, right? What important? Remember that the key is collaboration between the data part and also the domain knowledge. But in order to part can work together, collaborate together, you need to speak in the same language, right? You need to learn the language. At least you know the terminology. Let's say if you here is all the SPE member. I don't know what is your background, right? But you need to start exposing you to some of the language of, for example, the data analytics. You need to know what is big data, right? What is machine learning? Doesn't have to be an expert, but at least you know. So when you have a project and then you bring in data scientists, you can tell that this is the data, this is the context, and then when the data scientist saying that, oh, we need to do this, at least you can follow up, follow the conversation, and that's where the collaboration start happening. And you're willing to work together. You need to break in silo. You're no longer in the world that you have to do everything by yourself. You need to willing to find help and then willing to work together with other. Being the data science citizen means you need to understand the data is an asset, is important. So for sure, you need to make sure the data is always in good quality, right? And then always thinking how I can leverage the data and taking the benefit of it, right? You need to willing to embrace any technology. For example, I used to design trajectory manually. Now I have a application like DrillPlan can automatically design trajectory. Are you willing to say that, okay, I'll give a chance. Let the machine propose the best trajectory. And if it's better, then you come with this is better. Then yeah, rather than you're afraid, oh, my job is gonna be taken over by the machine. So we need to willing to leverage this technology and embrace to do your job better. And of course, as there's many things happening, and this is still in early journey of digital transformation and continue progressing, you need to continue self-learning, adapt, and innovate, right? So, so this is some of the keys that rather than people talking big data, what important is willingness people to collaborate. Right? So that's the end of this. This is my last slide. The key takeaway is, yes, digital transformation is already happening and is growing fast in the well construction and also in other sector, right? Production, completion. People are trying to use those different digital technology to help people on those different domain on how you doing reservoir engineering, geomechanics, and everything. And we are learning from other industry, right? You see the some example. For example, we are trajectory design. We learn from how is mapping application. We learn from how visualization in other industry, right? And we are in the journey to no longer just to automate things, but we want to achieve a system that fully autonomy, right? Smart system that can learn from the past experience and then quickly understand if something happened and then can faster react rather than human trying to to handle it manually. To achieve this, there is always need to change the culture, right? We need to collaborate more, to be open, and try to continuously innovate. And we welcome with this changing culture and the technology, and we willing to do things in a new way, right? So that's all. Sorry, I need to change this one. So I say thank you, and now I'm open for any question or comment, and we can discuss further anything that you want to know about digital transformation, or even I open if anything you want to know about what happening in the oil and gas industry right now with the sustainability and everything. All right, I pass it back to the moderators. Hello.
Hello, Mr. Henrik. I believe
Okay.
that Askar have just some connection issues.
Okay, no problem.
So, guys, if you have any question, you can write it down in the chat box, or you can raise your hand, and we will unmute you so you can ask your question directly.
No question. I'm making everybody lost, or
So, I believe there's no question till now.
Mr. Henrik,
yes.
Okay,
no
Askar,
further questions, I suppose.
Okay.
Yeah. Are you finished yet, or?
Yes.
Okay, cool.
Mr. Hendrik, just have a question. Currently, we are at the fourth stage, and you know we all have the project that we want to do, like a research.
Yeah.
So, do you recommend that the research will be about the digital transformation and the drilling, and in which topics exactly that you recommend?
Is it first before that? Did you? I need to ask. Do you have some basic knowledge being being exposed to like doing a simple machine learning, or doing the data processing in as part of your study?
Yeah, no, it's not part of my study, but I believe I joined some online courses during
I
the
see. Okay.
coronavirus. Yeah, so
Yeah. 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 So then, I mean, yeah, if you can give a try to apply some of those knowledge, then will be perfect. The challenge is, of course, for example, like machine learning, they require a data, right? And sometimes I can understand if you are in the university, sometimes the access to the data that for you to use or your research, sometimes is the limited, right? So this is require help from the university to have relationship with the industry, for example, drilling
yeah,
company or operators in Iraq, that they're willing. Okay,
yeah,
I can work for the company. I just need to access to the data. You can willing to keep everything confidential as long as I use it. So yes, sometimes the challenge of that. If you can get that opportunity, that will be perfect, because that's what many things happening right now. But yeah, sometimes it require help from university and also from external uh, part, like the oil company or service company or whoever can give you those data, right?
yeah. And in Iraq, they provide us with the data, but they just disappear the well name and the field name.
Yeah, yeah. That
So
will be fine. Yeah.
yeah.
So no further questions? Any questions? Yusuf, any questions?
No, that's fair enough for me.
Thank you. Thank you. Mr. Henrik Suryadi, we're
Yeah.
very glad that we had the chance to invite you here with us today. And we're so grateful. We aspire to have you again in some future sessions. Thank you. Very grateful, Mr. Henrik.
No, again, for me, it's an honor. I was so surprised when you invited me. I was surprised, but I'm always happy to speak with the student, because I also starting pretty much same as you, like 20 years back as a student, right? At that time, I didn't even know oil and gas industry, right?
And we also hope to end up like you, actually, especially me.
Yeah, I hope what I present today is giving you an idea what can be the futures and how you can prepare yourself, especially when you're still in the university, and how you entering the industry. At least you already have that perspective, right? And last thing, normally I got this question from student in terms of how is the future of oil and gas, right? Especially with all this climate change, the spirit of sustainability, many things that oil and gas industry will be die soon, right? I can tell you that it will not happen, right? The reason is it's not like I don't care about climate change. Yes, climate change is an issue. We need to fix the way the thing we emitting those carbon, otherwise it causing problem with our earth, with our futures, right? But the thing is, the other side of it is, yes, oil and gas contribute to those emission, but on the other side, oil and gas been bringing the benefit of energy, right? Either electricity or the fuel that we use for this 100 years of economic development, right? Many countries will, and there's still many people on the earth do not get even access to electricity or get this fuel. So the number of population is growing. We still need the energy, and that energy have to be economic, right? I cannot just say that, okay, let's stop oil and gas and everything replaced with the solar panel or with the wind turbine. It's fine if there is already economic by itself. It's gonna grow faster, and then people will not look at oil and gas energy, right? The economic will straight away doing that. But right now, those technology is still growing and still not as cheap as oil and gas, and it will take time because the economic become a balance, and then it will replacing each other. So even the current prediction from many agency, we're still looking at. So let's say in your age right now, in your 20, let's say you're gonna aiming for career for what, 30 years, 40 years ahead. I can tell you until 2050, which is 30 years from now, oil and gas still is some source of the energy. We're trying to not increase the amount of energy from oil and gas, but the increase of the energy requirement will be filled with those renewable. And the other thing is the industry that can help solving those challenge, building those solar panel, building the industry is oil and gas, because oil and gas know how to dealing with the bigger project. If you see that solar farm, wind turbine, wind farm, that's a big project, and oil gas know how doing that by drilling many wells. So the other side is we continue trying to make our operation is less emission, how we can reduce the amount of waste we do by whatever is we burning and everything, pumping it back to the earth. And oil gas the one who knows how to do that, including now we are helping other industry like cement, a steel factory, taking the excess of the CO2 from the factory. We help them taking all those things and then pumping it back to the earth. Oil and gas, who knows how to do that? We've been drilling a well, not just producing thing out, but also we pumping things down, right? So this industry will stay far, probably until 2100 and beyond, right? Because we just need to convert our knowledge, and now with the help of digital, how to make things is more efficient on this area. So that's just last thing I want to say, because normally when I speak to students, they always want to know, is there still a future in this industry? The answer is pretty much, I can guarantee you, there's still a future. All right, we just need to ready to be adapt, right? Probably in the future, we're not drilling oil and gas. We're start drilling well to pumping carbon. And also, a couple months ago, I got a call that is from the nuclear power plant. The plutonium road, after 10 years, 15 years, is a waste, and they're wondering, what is the best way to throw away this waste? Can you pumping it down, like say 1,000 feet underground? Well, we need to figure out how to push down a radioactive equipment material in a solid condition down to the ground. But this is the safest way to store it, is far away from people in the surface. But yeah, they come to us on, is it possible or not? Right now, they just dump it in a big cave somewhere, right? That's all. So I hope it give you perspective on it.
That's finally some good news.
Yeah.
Thank you, Mr. Hendrik, for accepting the invitation, and thank you for boosting our morals, because we're pretty down nowadays. Thank you again, and we shall see you in some future sessions.
My pleasure. Okay, thank you, and
Glad to
good
meet
evening.
you. Thank you.
Bye-bye.
Dear attendances, now you are supposed to fill the forms of the attendance. It's just down below in the chat. السادة الحضور يرجى ملء استمارة الحضور. استمارة الحضور حاليا موجودة بالشات والرابط موجود. شكرا لكم.